Hello students, welcome to Noya. My name is Rizwan. I hope you all are doing well. So here in this video, we'll be discussing about polynomials. Okay, I have mentioned in the last video that from the next some videos, we'll be discussing about the second chapter of the class 10 NCERT textbook, polynomials. Okay, this is a very important chapter and very interesting also. Okay, so let's begin. Yeah, you can see chapter 2, polynomials. Okay, as an introduction, we know that polynomials are those algebraic expressions with whole numbers as the exponents of variables. Okay, such algebraic expressions are known as polynomials. Okay, for example, here you can see 5x cube minus 4x square plus x minus root 2. This is a polynomial because here look at here x is the variable. Okay, x is the variable. Here you can see x cube. Okay, x raised to 3. There 3 is the exponent of x. 3 is a whole number. Then here you can see minus 4x square. Okay, minus 4x square. Okay, there 2 is the exponent of x. 2 is a whole number. Similarly, here you can see x. Simply x means x raised to 1. Okay, x raised to 1. So there 1 is the exponent of x. 1 is a whole number. Okay, so here if you take this algebraic expression, sorry. If you take this algebraic expression, all the exponents of the variable x are whole numbers, 3, 2, 1. Okay. Okay, so we can say that this is a polynomial. Okay, so such algebraic expressions are known as polynomials. Okay, on the other hand, let's take this one. 1 minute. Yeah, let's take this one. 1 by x minus 1. Okay, 1 by x minus 1. Here you can see x in the denominator. Okay, x in the denominator. So it's not possible to get the exponent of whole numbers for this variable x. Okay, because x in the denominator means we will be having negative exponents. Okay, negative exponents. So that is not possible. Negative numbers are not they are not whole numbers. Okay, so this is not an algebraic expression. Sorry, this is not a polynomial. It's an algebraic expression, but it's not a polynomial. Okay, now let's take this to root this expression root x plus 2. Okay, root x plus 2. Here you can see root x. Root x means x raised to 1 by 2. Root means exponent 1 by 2. Okay, exponent 1 by 2. Their exponent is 1 by 2. 1 by 2 is not a whole number. Okay, 1 by 2 is in between 0 and 1. It's not a whole number. Okay, so this is also not a polynomial. It's an algebraic expression, but it's not a polynomial. Here also you can see x square plus 2x plus 3 in the denominator. So we cannot find the exponent as, we cannot find the whole numbers as exponent here. Okay, because the variable is in the denominator, so you will find the negative exponents. Okay, so this is also not a polynomial. Okay, but all these are algebraic expression. Okay, so this is simply polynomials. Okay, now we can divide the polynomials into many types. Okay, we have many different types of polynomial based on the degree. Okay, what is mean by degree of a polynomial? What is mean by degree of a polynomial? Degree of a polynomial means highest exponent of the variable. For example, let's take this polynomial 5x cube minus 4x square plus x minus root 2. Let's take this. Here, which is the highest exponent of the variable x? Here, if you take this is x raised to 1. There, the exponent is 1. If you take this minus 4x square, there the exponent is 2. But if you take this 5x cube, there is the exponent is 3. So 1, 2, 3. Which is the greatest number among 1, 2, and 3? 3 is the greatest number, right? So 5x cube. This is the, here you can see the greatest exponent, okay? Or the highest exponent, that is 3. So the highest exponent of this polynomial is 3, okay? Highest exponent of the variable in this polynomial is 3. So we can say that the degree of this polynomial is 3. Okay, so degree of a polynomial simply means highest exponent of the variable. Okay, if you want a different example, let's take this one. X cube plus 1. Okay, x cube plus 1. Here again, you can see x cube. There the exponent is 3. Next one is 1. There you cannot find x. So the exponent is 0. Okay. So here you can see x cube, x raised to 3. Okay. So if we compare 3 and 0, 3 is greater. So here we can say that 3 is the highest exponent of the variable here. So here in this polynomial also, 3 is the degree. Okay. Let's take another example. Let's take another example. Yeah. 2x square plus 3x minus 2 by 5. Okay. Okay. This one. 2x square plus 3x minus 2 by 5. Here you can see 3x. 3x simply means 1 is the exponent. Here 2x square. 2 is the exponent. Comparing 2 and 1, 2 is the greatest. Okay. So here the highest exponent of the variable is 2. So we can say that 2 is the degree of this polynomial. Okay. So simply degree of a polynomial means the highest exponent of the variable. Okay. And we have different names based on this degree of the polynomial. Okay. We can name the polynomial based on this degree. Okay. Here you can see linear polynomial. Okay. Linear polynomial. Linear polynomial means polynomial with degree 1. Okay. If you have a polynomial with degree 1, then we can call that polynomial as linear polynomial. For example, you can see 2x minus 3. Here you can see simply x, that is x raised to 1. No other higher powers. So this 1 is the highest exponent of this variable. So we can say that 1 is the degree of this polynomial. Okay. In the same way, you can see all these polynomials. Okay. All of these are examples for linear polynomial, because in all of these polynomials, you can see the degree of the polynomial as 1. Highest exponent is 1. Okay. So such polynomials are known as linear polynomials. After that, we have quadratic polynomial. Okay. Quadratic polynomial. Quadratic polynomials are those polynomials with degree 2. That means if you have a polynomial with highest exponent of the variable equal to 2, then such polynomials are known as second degree polynomials or quadratic polynomial. Similarly, if you have a polynomial with degree 3, that means if you have the highest exponent, if you have the highest exponent of the variable equal to 3, then we can that polynomial as cubic polynomial. Okay. So in this way, we can name the polynomial based on the degree of that. Okay. Next concept is a very important concept regarding the polynomial, that is zero of a polynomial. Okay. Zero of a polynomial. Zero of a polynomial means if you put that number, it's a number. Zero of a polynomial means a number. It's not zero. It's not necessarily zero. Sometimes you will find zero, but it's not necessarily zero. It's simply a name. Okay. It means a number. Okay. It's a number. What is the peculiarity of that number? If you put that number in the place of x in a polynomial, that entire polynomial becomes 0. Okay. Such numbers are known as zero of the polynomial. Okay. Here you can see. Yeah. Let me give you one example. Let's take a polynomial. Okay. Here I'm taking a polynomial. X square plus 7x plus 12. Okay. Here we have a polynomial. Let's call it as P of x. Okay. P of x equal to 1 minute, please. P of x equal to x square plus 7x plus 12. Okay. Yeah. Now here in this polynomial, I'm going to put minus 3 in the place of x. Okay. Let's see what will happen if you put minus 3 in the place of x. Okay. Okay. Yeah. Now this polynomial is P of x. If you are putting minus 3 in the place of x, this P of x becomes P of minus 3. Okay. P of minus 3. Similarly, if you are putting minus 4, this becomes P of minus 4. If you are putting 10, this becomes P of 10. If you are putting 100, this becomes P of 100. Like that we can name. Okay. So first we are putting minus 3. So this polynomial P of x becomes P of minus 3. That means wherever you can see x, you can put minus 3 in the place of that, or you can substitute minus 3 for x. Okay. So what will happen? First one is x square. That becomes, if you put minus 3 in the place of that x, that becomes minus 3 square. X square minus 3 square. Just minus 3 in the place of x. Okay. Plus 7x. 7x means 7 into x. There also you can put minus 3 in the place of x. So it becomes 7 into minus 3. Okay, plus 12. No change for that because there is no x. So this you will get as the expression if you put minus 3 in the place of x. Now we can simplify this. Okay, we can simplify. So this becomes minus 3 square becomes 9, right? Minus 3 into minus 3 is 9. Similarly, 7 into minus 3. Okay, what is 7 into minus 3? That is minus 21. Okay, plus 12. So 9 minus 21 plus 12. Okay, that is equal to what is 9 minus 21? That is minus 12. 9 minus 21 is minus 12. So minus 12 plus 12. Okay, minus 12 plus 12. Minus 12 plus 12 you can cancel. So both will vanish. You will get 0. That means after putting minus 3 in the place of x in this polynomial, you are get that entire polynomial becomes 0. So we can say that minus 3 is a 0 of this polynomial. Okay. Similarly, let's put minus 4 in the place of x. Okay. First, we have tried with minus 3 and that entire polynomial became 0. So we can conclude that minus 3 is a 0 of this polynomial. Now let's try with another number 4. Okay, 4. So if you put 4 in the place of x, this becomes, sorry, not 4, minus 4. I'm sorry, minus 4. Okay, so here I am going to put minus 4 in the place of x. If you put minus 4 in the place of x, p of x becomes p of minus 4. Simply minus 4 in the place of x. Okay, that is equal to first one x square. That x square becomes minus 4 square. Okay, minus 4 square plus 7x. That becomes 7 into minus 4. Okay, 7 into minus 4 plus 12. Okay, that is equal to minus 4 square is 16. Okay, minus 4 into minus 4 is 16 plus 7 into minus 4 is minus 28. Okay, so 16 minus 28 plus 12. Okay, what is 16 minus 28? 16 minus 28 is nothing but minus 12. So minus 12 plus 12. Again, this is equal to 0. That means after putting minus 4 also in the place of x, you are getting the entire polynomial reduced to 0. So we can conclude that minus 4 is also a 0 of this polynomial. Okay, now let's try with another number. Let's try another number. Which number you want? Let's try 5. Okay, 5. That means if we are going to put 5 in the place of x. If you put 5 in the place of x, p of x becomes p of 5. That is equal to x square becomes 5 square. 5 square plus 7x becomes 7 into 5 plus 12. 5 square plus 7 into 5 plus 12. That is equal to, what is 5 square? It's 25 plus 7 into 5 is 35 plus 12. That is equal to 25 plus 35 is 60. 60 plus 12 is 72. What's happening here? Here we got 72 after putting 5 in the place of x in this polynomial. It's not 0. It's different from 0. Okay, we got a different number, 72. So 5 is not a 0 of this polynomial. Okay, because after putting 5, we are not getting 0. So minus 3 and minus 4, these two are zeros of this polynomial. Okay, so that is simply 0 of a polynomial. Okay, that is also very important concept. Okay, next we have some relation between coefficients of a polynomial, coefficients in a polynomial and its zeros. Okay, coefficients and its zeros. Okay, before coming to that, you should know about the general form of a polynomial. Okay, general form of a linear polynomial, general form of a quadratic polynomial, and a general form of a cubic polynomial. Okay, so let's discuss the general form. Okay, general form means form entirely with algebra, without numbers. Okay, so let's discuss the general form of these three polynomials. Okay, we have linear polynomial. Linear polynomials are those polynomials with degree 1, then quadratic polynomial with degree 2, then cubic polynomial with degree 3. Okay, yeah. Now let's write the general form of a linear polynomial. Okay, linear polynomial, we have the general form ax plus b. Okay, this is the general form of a linear polynomial. Okay, after that we have quadratic polynomial. For quadratic polynomial, we have the general form ax square plus bx plus c. Okay, this is the general form of quadratic polynomial. Okay, all are with a, b, and c. Actually, we have numbers in the place of this a, b, and c. Okay, a is representing a number, b is representing a number, c is also representing number. Okay, here also. But generally speaking, we will use only algebra. Okay, a, b, and c. It can take any numbers. It can take any real number. Okay, and the third one is we have quadratic, and the third one cubic polynomial. Okay, cubic polynomial. Cubic polynomials are polynomials with degree 3. Okay, I told you in the beginning. So this becomes, general form becomes ax cube, ax raised to 3 plus bx square plus cx plus d. Okay, cx plus d. Okay, so these are the general forms of polynomials. Okay, general form of a linear polynomial is ax plus b. General form of a quadratic polynomial is ax square plus bx plus c, and general form of a cubic polynomial is ax cube plus bx square plus cx plus d. This is the general form. Okay. Okay, because here we know that linear polynomials are those polynomials with degree 1. That means you can see the power 1 here. Okay, x means x raised to 1. Here this is the highest power, so the degree is 1, so linear polynomial. The next one, quadratic polynomial. Quadratic polynomial means with degree 2. Here you can see 2. Okay, 2 is the highest power, so 2 is the degree, so this is a quadratic polynomial. Then you can see cubic polynomial. Cubic polynomial means degree 3. Here you can see 3 is the highest exponent here, so cubic polynomial. Okay, so and for numbers you can represent a, b, c, and d. In some cases this a, b, and c become 0 also. That is also possible. Okay. Okay, now these are the general forms of linear polynomial, quadratic polynomial, and cubic polynomial. Okay, then we can represent the zeros of the polynomial. Okay, zeros of the polynomial using alpha, beta, and gamma. Okay, that I will explain later. Okay, we will come to that. Okay, first understand that these are the general forms of polynomials. Okay, for linear polynomial you have x plus b, quadratic polynomial ax square plus bx plus c, and for cubic polynomial we have ax cube plus bx square plus cx plus d. So understand that these are the general forms. Okay, we will use the general form. So these are the coefficients a, b, c, and d. All these are the coefficients. Okay, I told you that we will come to the relation between coefficients and zeros. Okay, so understand that these are the coefficients. Before that, we have to discuss little more topics. So after that, I will explain the relation between them. Okay. Now, let's discuss the next topic. Geometrical meaning of zeros of the polynomial. Okay, I've explained about the zeros of the polynomial. Okay, I hope it's clear for you. Now, what does this geometrically mean? Okay, so in this section, we will discuss that. Okay, geometrical meaning of the zeros of the polynomial. For that, we need the graph of the polynomial. Okay, we need the graph. For the polynomials, we can draw graph. Okay, the graph of a linear polynomial looks like this. It's a straight line. Okay, it's a straight line. Similarly, you can see the graph of a quadratic polynomial like this. This shape is known as parabola. Okay, similar to U. Okay, capital U in the English alphabet, but not exactly like that. Okay, but some similarity. The graph of a quadratic polynomial looks like this. Then you can see the graph of cubic polynomial. Let me take the graph of a cubic. Yeah, it will look like this. That means for any polynomial, we can have its graphs. Okay, you can represent it geometrically. You can draw the graphs of the polynomials. Okay, so here our topic of discussion is the geometrical meaning. Okay, geometrical meaning of the zeros. I have explained the zeros, but what does it means geometrically? What is the meaning of that? The meaning of the geometrical meaning of the zeros is nothing but regarding the graph of the polynomials. Okay, graph. Okay, so we know that for graph we have x-axis and y-axis. Okay, we have x-axis and y-axis in any graph. Okay, for graph we need this x-axis and y-axis. Okay, and I already told you that for polynomials we can draw lines. Okay, we can draw graphs. Okay, this is the graph of a linear polynomial. It looks like this. It's a straight line. Okay, now you can see that this graph, this straight line is intersecting the x-axis, right? It is intersecting the x-axis at this point. You can see the point. Okay, that point, the x-coordinate of that point is the 0 of this polynomial. So this is the geometrical meaning of the 0 of a polynomial. I am repeating, 0 of a polynomial means that point, the x-coordinate of that point. Which point? The point at which the graph of that polynomial is intersecting the x-axis. If you draw the graph of a polynomial, you can see the intersecting point. Okay, in some cases you cannot find, but in most of the cases, or in the other cases, you can find the graph is intersecting the x-axis, and the x-coordinate of that point or that intersecting point is known as 0 of the polynomial. So this is the geometrical meaning of 0 of a polynomial. Okay, here you can see at how many points this graph is intersecting the x-axis. Only at this point, right? Intersecting at y-axis this point, but here we want only x-axis. Okay, so this line, this straight line is intersecting the x-axis only at this point. So we can say that for this polynomial we have only 1 0. Okay, we have only 1 0. And this is a peculiarity of a linear polynomial. This is a graph of a linear polynomial. I already told you. Okay, for a linear polynomial, at most, maximum we can have 1 0. This is very important. Okay, for every linear polynomial, the maximum number of zeros equal to 1. Okay, greater than 1 zeros is not possible for linear polynomial. Okay, you can find linear polynomial without 0. That is possible. Without a 0, that means 0 0. That is possible. And 1 0. Greater than 1, not possible, because that 1 is the limit. It's the maximum limit of number of zeros of a linear polynomial. And what is the degree of this linear polynomial? It's 1. That I told you in the beginning. The polynomial with degree 1 is known as linear polynomial. And for that linear polynomial, it can have maximum 1 0. So degree 1, maximum number of zeros, 1. I hope you can see the connection. Okay, linear polynomials are those polynomials with degree 1. Degree 1. And how many zeros possible? 1 0, maximum 1 0. Okay, see the relation between them. Okay, see the connection. Similarly, let's move to the quadratic polynomial. Yeah, I told you the graph of a quadratic polynomial looks like this. Okay, a parabol shape. Now it's intersecting the x-axis at how many points? 2 points. Okay, you can see 2 points. And no other points are possible. Okay, because it is going like this and this is going like this. No other zeros are possible. It's not possible to intersect it again. That means for this polynomial, for this quadratic polynomial, we have 2 points of intersection on x-axis. That means we have 2 zeros for this polynomial. Okay, we have 2 zeros. Okay, and that is the maximum number of zeros possible for a quadratic polynomial. Okay, 2. So for a quadratic polynomial, maximum you can have 2 zeros. Okay, 2 zeros. Below 2 is possible, but above 2 is not allowed. Maximum is 2. You can have 1 0 and you can have 0 zeros also. You can find quadratic polynomial without zeros. That is also, even that is possible, but greater than 2 is not possible. Again, what is meant by a quadratic polynomial? A polynomial with degree 2. So polynomial with degree 2 is known as quadratic polynomial, and maximum number of zeros is equal to 2. Degree 2, maximum zeros 2. Again, you can see the connection between the zeros and the maximum number of zeros and the degree. In the linear case, degree is 1, maximum zeros is 1. In the quadratic case, degree is 2, maximum zeros is also 2. Okay, so you can guess about the cubic polynomial. Okay, for cubic polynomial, this is a graph of a cubic polynomial. 1, 2, 3. It is intersecting the x-axis at 3 points. Okay, and we know that for cubic polynomial, the degree equal to 3. So for cubic polynomial, degree equal to 3, maximum zeros possible, 3. Below 3 is possible, but above 3 is not possible. That's why maximum. Okay, so this is a very important concept. Okay, the relation between degree and the number of zeros. Okay, if the degree is 1, maximum zero is 1. If the degree is 2, maximum 0 is 2. If the degree is 3, maximum 0 is 3. Okay, like that. Okay, and one more topic. This is regarding the graph only. I hope you're already familiar with that. Drawing the graph. Okay, I explained this graph of this graph. Okay, this graph is a quadratic polynomial of x square minus 3x minus 4. Okay, now I'm going to tell you the method of drawing graph. Okay, method of drawing graph of a quadratic polynomial. Okay, here the polynomial is this one, x square minus 3x minus 4, x square minus 3x minus 4. You can see the graph of this polynomial here. This graph is representing that polynomial, x square minus 3x minus 4. How can we draw this graph? For that, you can convert it into an equation. Y equal to x square minus 3x minus 4. Whatever be the polynomial, equate it to y. Here the polynomial is x square minus 3x minus 4. So simply write it like this, y equal to x square minus 3x minus 4. Then you can convert it into an equation. Here you can see y, because y is required here, because we have y-axis and x-axis. Both axes we have. Okay, x square minus 3x minus 4, that is x, but where is this y? You can see this y here. You can equate it to y. Okay, so and after that you can put each values for x. You can put 0 for x. You can try many values for x. You can put any value for x. Okay, you can put 0. If you put x equal to 0, you can see y, you will get minus 4. That also I have explained. If you put one value for x, that entire polynomial becomes another value. Okay, if that entire polynomial is becoming 0, then that value is known as 0 of the polynomial. That I already explained. That means if you put any number for x in the polynomial, you will get the corresponding value of that entire polynomial, and that is equal to y. Okay, that means if you put 0 for x, you will get minus 4 as y. That entire polynomial becomes minus 4. That is y. If you put 1 for x, that entire polynomial becomes minus 6. If you put minus 1 for x, that entire polynomial becomes 0. So here the y is 0. If you put minus 2 for x, that entire polynomial becomes 6. Here the y is 6. If you put 3 for x, that entire polynomial becomes minus 4. Here y is minus 4. So similarly, you will get x, y, x, y, x, y, x, y. Okay, you will get many. If you put any value for x, you will get the corresponding value for y. So x, y, x, y, x, y, all these are coordinates. X coordinate and y coordinate. X coordinate, y coordinate. Here x coordinate is minus 2, y coordinate is 6. X coordinate is minus 1, y coordinate is 0, and so on. So all these are points. So with the help of these coordinates, you can put all the points on this graph. And if you join all these points, I hope you know how to draw, how to join the dots and draw something like that only. Okay, we tried this in our childhood days, right? Connecting the dots. Like that, you can find many points based on these coordinates, x, y, x, y, x, y, and take the points here and connect all these, you will get the graph. Okay. So in this way, you can draw the graph of polynomials. Okay. So these are the topics of our today's discussion. Okay, I hope everything is clear for you and you have enjoyed the session. Okay, so in the next class, in the next video, we'll be discussing the remaining topics, okay, of the same chapter. Okay, we'll discuss some important chapter. There we will discuss the zeros, the relation between zeros and the coefficients in a polynomial. Okay, that is a very important concept. Okay, so thank you, students. Thanks for watching. So yeah, take care. Bye-bye.